The universe is going to end. That's not a theory, that's not a doomsday headline, that's just physics. Every model we have points to some version of the same conclusion. The argument is just about how, and the options are so varied, so genuinely unhinged, that scientists have had to invent entirely separate categories of apocalypse to contain them all. We're not talking about one extinction event. We're talking about multiple completely different ways everything, not just life, not just Earth, not just the galaxy, but everything stops existing. And some of these scenarios are so extreme, they don't just end the universe, they unmake the concept of matter itself. Here's the part that should actually mess with your head. We don't know which one is coming. We can narrow it down based on what we currently understand about dark energy, quantum mechanics, and thermodynamics, but the honest answer from cosmologists right now is that the fate of the universe depends on measurements we haven't been able to make precisely enough yet. One number, the density of dark energy, could tip the whole outcome from one ending to a completely different one. Everything that follows is real, peer-reviewed cosmology. And every single one of these is on the table simultaneously. Buckle up. We're about to run through every serious model for the end of everything. The leading candidate right now is called the heat death of the universe, also known as the Big Freeze. And it is somehow both the most boring and most horrifying thing you will ever hear.
The second law of thermodynamics says entropy, basically disorder, always increases in a closed system. Everything tends toward the most disordered, most spread out state possible. Heat flows from hot to cold until everything is the same temperature. Stars burn fuel until they run out. Eventually, every star in every galaxy in the observable universe will have burned through every gram of fusible material. The last red dwarfs, the smallest, most miserly stars, will die out somewhere around 100 trillion years from now. After that, no new stars form. Black holes slowly evaporate over timescales so long the numbers barely parse as language. The largest ones taking around 10 to the power of 100 years to fully disappear through Hawking radiation. And when the last black hole finally fizzles out, the universe is left as a thin, cold, nearly uniform soup of photons, neutrinos, and elementary particles drifting apart forever at a temperature approaching absolute zero. Nothing happens. Nothing can happen. No gradients exist to drive any process. No structure, no chemistry, no signal of any kind. The universe doesn't explode.
It doesn't collapse. It just idles at maximum entropy, forever, doing absolutely nothing. That's the Big Freeze. And the current data on dark energy expansion suggests this is the most probable outcome. But here's where it gets genuinely savage. Right now, the universe is expanding. Not just expanding, accelerating. Something called dark energy is pushing galaxies apart faster and faster. And if that acceleration doesn't stay constant, but instead keeps increasing, the result is a scenario called the Big Rip. And it is exactly what it sounds like. In the Big Rip, dark energy doesn't just pull galaxies apart. It keeps amplifying until it overpowers every other force in physics, one by one. First, galaxy clusters get shredded apart. Then individual galaxies get torn. Then solar systems. Then planets.
Then atoms. Then the nucleus of every atom. Then subatomic particles. Every structure in the universe, every bond, every force, every interaction rips apart in a cascade that ends with space-time itself tearing open. The final moment before the Big Rip arrives has been estimated at roughly 22 billion years from now, if the Rip scenario holds. In the last fraction of a second, every atom of matter in existence simultaneously detonates. Not into something, into nothing. Because there's nothing left for matter to be made of. The universe doesn't end. It gets deleted. Now, flip it. What if dark energy isn't accelerating indefinitely? What if it eventually reverses? Then gravity wins. And when gravity wins cosmologically, the result is the Big Crunch. In this scenario, expansion slows, stops, and reverses. Galaxies stop fleeing each other and start falling back together. The temperature of the universe rises as everything compresses. Galaxies merge, stars collide. The cosmic microwave background, the faint afterglow of the Big Bang, heats up from a few degrees above absolute zero to thousands of degrees. The night sky stops being dark. Every direction you look is as bright as a star's surface. Eventually, all matter compresses into a single, incomprehensibly dense point, a state identical to the conditions at the Big Bang. And here's where it gets philosophically spicy. Some physicists think that singular point could bounce, triggering a new Big Bang, a new universe, a new cycle. This is called the ekpyrotic or Big Bounce model. The universe wouldn't just end, it would restart. Whether that's comforting or terrifying probably depends on your personal relationship with Tuesday mornings. This is the one that should make you existentially uncomfortable. Forget billions of years. This one could have already started somewhere, and you would never know until it was too late. Quantum field theory describes the universe as existing in what physicists call a vacuum state, the lowest energy state of the quantum fields that make up reality. The problem is, we don't actually know if our current vacuum state is the true lowest energy state, or just a metastable false vacuum. A ball sitting in a valley on a hillside isn't at the lowest possible point. It's at a local minimum. Quantum tunneling, the same mechanism that lets particles pass through barriers they classically shouldn't, could theoretically cause the universe's vacuum to tunnel to a lower energy state. If that happens somewhere, and it only has to happen once, anywhere in the observable universe, it creates a bubble of true vacuum, expanding outward at the speed of light. The bubble wall isn't something you can see coming because it travels at exactly the speed of light, meaning no warning, no signal, nothing reaches you first. The moment it hits, the laws of physics change. Not gradually, instantly. Every atom of matter is rearranged by an entirely different set of physical constants. Every structure built from current physics matter, every particle, every force, every interaction ceases to exist in any recognizable form. The bubble doesn't destroy you. It rewrites the rules so thoroughly that you can no longer be a coherent concept. Some cosmologists think vacuum decay is unlikely because our vacuum has been stable for 13.8 billion years. Some think that's not actually that long on the relevant timescales. Nobody knows. And critically, we can't rule it out. Related but distinct, Higgs field instability. The Higgs field gives particles their mass. Measurements of the Higgs boson mass from the Large Hadron Collider put it in a range that suggests our Higgs field might be in a metastable state, meaning it could quantum tunnel to a lower energy state, collapsing the field. If the Higgs field collapses, particles that currently have mass lose it instantly. Electrons stop orbiting nuclei. Atoms dissolve. Chemistry stops being possible. Matter as a concept becomes unavailable. The effect again propagates at the speed of light from wherever it starts. And wherever it starts, everything within its expanding sphere gets erased. This one has a nickname, the Big Slurp. Because the Higgs field doesn't explode anything. It just quietly drains the fundamental property that makes matter solid and real, leaving a universe where the particles are still technically there, but completely unable to form anything. Imagine turning off the mass property of existence. Everything falls through everything, forever, doing nothing. Step back for a second. What if endings are also beginnings? The Cyclic cosmology models, including work by physicists like Roger Penrose and his conformal cyclic cosmology, suggest that what we call the Big Bang might not be a beginning at all, but simply the current universe's Big Crunch in disguise. Penrose's model argues that in a sufficiently old universe at maximum entropy, all massive particles have either decayed or been consumed by black holes,
leaving only massless particles, like photons. Massless particles don't experience time in the conventional sense. At that scale, the concept of size becomes meaningless. A photon doesn't know if it's in a vast, old, cold universe or a tiny, hot, young one. So the end state of one universe is geometrically identical to the beginning of the next, and the whole thing cycles. The evidence for this, Penrose claims, exists in the cosmic microwave background, faint circular patterns that might be gravitational wave echoes from supermassive black holes colliding in the previous cycle of the universe. This is genuinely contested science, but it's real science, done by one of the most significant theoretical physicists alive. Here's where it actually breaks down in an interesting way.
Every single scenario above is dependent on one thing we don't fully understand: dark energy. We know it exists because the universe's expansion is accelerating, and something must be causing that. We've named it, we've measured its effects. We have absolutely no idea what it is. If dark energy is a true cosmological constant, Einstein's lambda, the big freeze wins. If it's a dynamic field that increases over time, the big rip wins. If it reverses, the big crunch wins. And underlying all of it is the quantum vacuum question, which means vacuum decay is sitting quietly in the corner of every model, never ruled out, never confirmed, just there. The fate of the universe is, in the most literal sense, a matter of one number we haven't measured precisely enough. Everything else is just conditional planning. Science doesn't break here exactly. It just reaches the edge of what we can currently observe and sits down. So the universe ends in one of at least 5 meaningfully different ways. The answer depends on a number we don't know. One of the options could have already begun somewhere and you never know. And a credible physicist thinks the whole thing might loop back and start over anyway. Everything we've ever called real, every atom, every force, every structure, is sitting somewhere inside one of these timelines, waiting. You made it to the end, which means the exit fee is due. 1 subscribe, that's the toll. I'm flipping this tablet around like I'm expecting a tip on a bottle of water, and you're paying it in the form of a like. Don't, and I'm assuming your MHC molecules are incompatible with mine. And honestly, given what you just learned about vacuum decay, maybe don't leave things unresolved. Stay wrinkly, apes. See ya.